animated graphs. It's kind of like my nemesis, and I forget how to do it, and I need to do it. So I'm making a video, and this is for you, and you are future Rhett. I'm making it for me in the future so I can see how to do it. And here's what we want to make. We want to make an animated graph like this. Now I'm going to actually show you 3 different ways to make this animated graph, and this is going to be one of them. But let's start from scratch. And like I said, I just forget this stuff. I can't remember what I'm doing. I think a lot of the tutorials online, they're written for programmers, and newsflash, I'm just a guy. I'm just a physicist, not even a great one at that. So let's get started. Like I said, 3 ways. Now, my normal method, which I'll show you the last way, is to use web VPython, online Python, with, I think, has great animation, great graphing, but the problem with that is, since it's not real Python, it doesn't have the real NumPy, you can't do like the eigenvalue problem very easily. You can't deal with matrices. So in some situations, you got to use real Python. We're going to use real Python. So here's a case that we want to plot this sine kx minus omega t, and it changes with both x and t. So how do we do that? So one way is to make an animation with respect to time. So that's what we're going to do. Okay. So I'm in Python here. Nope, I'm in Python right here. I'm going to go ahead and start making my stuff. So let's just put in omega equals. No, I'm going to import my stuff. Import numpy as np. Import matplotlib.pyplot as plt. So the numpy has all my mathematical functions in it. Matplotlib has the graphing stuff. And again, I'm going to start over for the next method, so they'll all be separate programs, because sometimes they kind of don't like each other, so that's fine. Now let's just put in our constants. I'm going to say omega is equal to 2, k is equal to 4. I need to make my values for x and time. Okay, but let's just start with the x. So I want x to be, I'm going to say np.linspace from 0 to, I should say 4. And how many, and let's do 400. 400, so that, 401. So that will space them out in 400 numbers. And since I start at 0 and end at 4, I do want 1 extra. That's just a little trick. Okay. Now, I think what I'm going to do is to make my function, make a function for f, so that I can plug in my t values. Let's see if that works. So def f, and I'm going to plug in my t, and let's call that tt. I like to use different variables. And then I'm just going to say return np.sine. I'm looking at my equation. What was my equation? Kx minus omega t. So it's going to be k times x minus omega times tt, whatever value I put in there. So let's just test that. Let's just plot. Now remember, x is a function. X is an array. So I'm going to get a whole bunch of things, and I'm just going to plot. I'm going to say t equals 0, and now we're going to plot f plt.plot my x values and then my f values. I think this will work. Let's say f of t. Let's see what happens. Yeah, it did work. Okay. And so I didn't put labels on there and like that. I'm just focusing on the main aspect, not the superficial part. You can do the other stuff later. If I change this to t1, notice right here where that hump is. If I change it to t1, it moved over. Okay. So let's put that back at 0. Let's put dt at 0.5. Now I'm going to get rid of this plot. Now let's do this. While t less than 4, let's plot it. So I will say plt.plot x f of t, and then I'm going to increase my value of t. T equals t plus dt. So I'm going to make a bunch of graphs. I'm just going to make a bunch of graphs. Let's see if this does indeed work. Oh, it put them all in the same thing. That's not bad. That's not what I wanted. Maybe if I do this plt.show. I didn't think this through, did I? There we go. Okay. So you see here, it's if I scroll really fast, it's like an animation. I mean, you may think that's not, hey, that's not cool. It's not really an animation, but it gets what I want, right? I could even print out the time. Maybe that'll work. Print t equals t seconds. See if this works. 0 seconds, 5. See, that's pretty good, right? I mean, you got to admit, that's pretty good. I can see that it is indeed moving, right? So that's what I want. I mean, it's not great, but it works. And you don't have to do anything crazy. So I like this way. If you're a student and of mine, and I say you need to show how this wave function evolves over time, and you print out 5 graphs, done, that's acceptable. That works. That works for me. Okay, now let's do a slightly better method. This is the Matplotlib version. Okay, so I do have to import some different things here, and this is stuff that I forget. So I'm going to copy that over here, come down here, and paste it. Okay, so there's my, I do have NumPy, I have Matplotlib, and then I have this animation, FuncAnimation, function animation, and IPython display. One of the things I found was that I could do the FuncAnimation, but it wanted to save it as a GIF and things like that, and so that was a problem. I think this may or may not, I think this does work in Google Colab. So if you're doing it on an iPad and you don't have actual Jupyter notebooks, this should still work. Okay, so I'm gonna make my my variables again. So I'm just gonna copy those and put them down here. And again, I don't always know what everything does, and so you gotta play around with it, that's fine. So I have x going from 0 to 4, and I made my time, which I'm calling TP just temporarily, going from 0 to 4, and it's the same space. It's the same number of pieces, which I don't think you need, and we'll change that in just a little bit. We're gonna break this, okay? Next, I don't know if you need to do this, but the way I found it, it made a figure and an axis. Those are 2 different objects, and they are part of a subplot. And I'm not really good with subplots in Matplotlib, but that's what someone else did. One of the things that you have to do before you make the animation is you have to make one graph, right, to kind of set the size of everything. So let's do that. Let's just make one graph and line. I'm not sure why there's a comma here. Oh, it's part of that same subplot. I don't remember. But I'm just going to put this as axis.plot and x and np.sine k times x minus omega times tp, right? So I have tp since that's my time. Oh no, I want to do it as 0. Because I want to, that's going to set my boundaries for the whole thing. And let's just run that. And it didn't work. Non-iterable axis support. plt.subplot. Subplots. That's why. No, now too many variables expected. Oh, I got an extra. How to do that? See, parentheses. This shouldn't be there. There we go. Okay, so it's just a normal plot. Now I can go ahead and make my animation. So I'm actually going to have this extra graph left over. That's fine. So again, I'm going to make my function. And let's put it down here. Def f of t. And so I use tp up there, so it's fine. And it's going to be just... Now, I think I can just do this. Return np.sine k times x minus omega times t. So it's the same function, but I can pass it a number. Okay, I think that works. I think it might not work though, but let's just try. Again, this is for future Rhett. Now for the important part, I can make my animation. So Annie is my animation. It's the type FuncAnimation. Remember, capitalization matters. Figure is what figure I'm going to do. My function f. The frames, what am I going to pass it that's going to change? And that's my frames. So my frames are going to be TP. Right? That's my list of time values. And then I have interval. Let's put that at 50. So interval is the number of milliseconds between each frame. Now I need to add this in here, which is HTML Annie.2JSHTML parentheses. And I don't know why that is there, but let's just run this and see if it's going to work or not. Now, it should take a while. You notice here that my little asterisk means it's running. It's not going to give you the animation at all at once. It will give you an animation that you can replay, though, which is kind of nice. So that means that I have to fill this time with talking and wasting your time. Do you have any questions? It may, like I said, it may not work, 'cause I don't know everything I'm doing here. Okay, there, it's done. Okay, it did work. So here's my animation. I press play, and nothing happened. Isn't that great? Okay, let's do this. Let's try this. This is the way I saw it before, which I didn't understand, so I didn't do it. Line.set y data, like that, and then return line. And if you're like a great programmer, you may be looking at this saying, what are you doing? You don't know what you're doing. And that's correct. I do not know what I'm doing. And that's why I'm making a video. One of the best ways to learn something is to make a video. So here I am making a video for you. And by you, I mean me. Because like I said, I'm going to get this in the future. It finished. No, it didn't finish. I thought. So, still going to talk. You know, I found that, okay, here's my animation. There. Animated. So I'm pretty happy with that. Again, there's a lot of parameters online that you can change. The one thing that you may want to change is this interval. If I make that interval smaller, it will rerun the whole calculation, but then it'll play faster. But you have these controls down here, which is kind of nice. You can go back to the beginning. You can start it over again. I really do like the controls to replay it because it's already run. It's done everything. So now you can export it. So that's method number 2, and that's the one that you need to remember, Rhett, because that's the one you're going to forget. Now this next one, I do know how to do. Okay. Oh, I didn't. I made a nice little thing up there, but I didn't do it. Okay. So we're going to do a completely another method. Now I'm going to import some stuff, and then we'll make it. Let's see. Where did I put my? There it is. Okay, I just want to make sure I got the same numbers. Import numpy as in P, and now, no, that's not it. Where'd it go? There it is. And I'm going to import something that you might not have seen. Import VPython as VP. Now, here's where you might have a problem. If you are running Google Colab, you do not have VPython module. If you install Anaconda, you do not have VPython module. So what you can do is go to vpython.org and then click over here using VPython with an installed Python, and then using the VPython module outside of it, or read more. It should be, if you follow this, it should work. Yeah, I did it. It worked. There were some weird things though coming on. Okay, so VPython is the same as what we normally use in Web VPython, and we can use the VPython graphing, and that's what I want to do. Now there is one trick, okay, and I found this trick out before. It can get a little wonky. It becomes unwonky if you add a scene in there. So normally you'd have a scene as to make more than one display. But we need to do that, canvas, and I'm just going to put title equals stuff. It does not really matter, but I need that in there, okay? Now I can use my normal Web VPython stuff to make my animated graph. So I'm going to make a graph, I'm going to make a function to graph. So G1 equals VP.graph, X title equals X, no, it was time, Y title equals Y. And you can change the width and the size and all the stuff that you'd normally do. F1 is VP.gCurve. And remember, the difference here is that I'm pulling from the VPython module, so I have to tell it what module I'm getting it from. That's what that VP is for. And let's put this as color equals color. Oh, color equals VP dot color dot blue. So color is not built into Python. It's built into VPython. So I have to tell it where to get that color dot blue from. Now let's make our variables. W equal omega equals 2, K equals 4. And I'm going to make my arrays again. I'm going to make all my x's. I'm going to make all my times. X equal, actually, let's just make all my x's. Again, let's do it the same way. There's more than one way to do this. np dot linspace 0 to 401. Not 4001, 401. That's good. Now I'm going to make a function again for f. You don't have to do this. Def f of tt return np.sine k times x minus omega times tt. That'll return the value at that particular time. Just like before. Now I want to go through a bunch of times. So I'll do the same thing. T equals 0, dt equals 0.01, while t less than 4. Now I'm going to add a rate statement. vp.rate 100. So in the FuncAnimation, you control the animation rate with the interval. Here you control it with rate. So rate 100 says don't do more than 100 loops per second. So since I have a dt of 0.01, this would try to make it in real time if it can. Now to make an animated graph, what I'm going to do is to make a whole graph all at once and then do it again. So I need to start off with an empty list. I'll call it fdata equals an empty list. And now I need to go through and generate all my x values and add it to that list for this particular value of time. So for I in range length of x, I could probably do that a different way. I always do it this way. I don't know why. I need to put in my x value, put in my t value, and add it to the list. I can do it all in one statement. Fdata equals fdata plus my x value is going to be time, t. My y value is going to be f of t. No, that's not t. No, that needs to be like that. There's a second bracket. That's what it was. It's a list of list points. And that will make my graph. Now I can, once I'm done with that, I can, ooh, I got rid of my bracket. I can plot it. f1.data equals fdata. I can increment my value of t. T equals t plus dt. I think this will work. I did a little bit different before, but I think this should work. No, I did it wrong. That's right. This is my x value. And I want to do x of I. That's right. I'm plotting x versus f of x. The time is not plotting it versus time. I feel like it's not going to work. Running it. And it's still running at vp.rate. I made a bunch of errors. Maybe I should have done it a different way. Okay, switching to my other way. I'm going to copy this. I'll tell you what I did. Sometimes you gotta have a backup plan. Nothing wrong with a backup plan. Let's run this and see if this one works, and then I'll tell you what it does. It didn't do anything. Huh. Let's see, rerun this. Rerun this. Okay, backup window. Let's see if this one works. I have had problems with this. Okay, it's not always perfect. So here's my other version. Let's see if this one runs. So let's run this. Okay, that ran. I'm going to run this. Let's running? Oh, there it is. It did work. Okay. Let's run it again. Now, I do not have the controls, but it did work. So let me tell you what was different in this one, because I did a little bit different. I was trying to be creative and on the fly, thinking and, you know, spontaneously. It was a bad idea. So here I make the same thing up here. Here I make all my variables, but now I made all the times beforehand. Then I just go through all my times in a list. And that's like my while t lesson 4. This one, the VP rate did work. Again, I make the empty list, and then I just calculate. I didn't make a function for f. I just calculated it. My xj, and then my ti. So I'm changing t and I. So listen, it's a double loop, and then I plot it, and that worked, and that's pretty good. So let's just run that again. I'm gonna run this a little bit slower. Let's put it at 50, just so you can see what that looks like. And it does it, right? I'm pretty happy. You can add, I put my labels there. I can make the whole thing smaller. You can change your parameters. I don't think it's as robust as the FuncAnimation, but it's one that I understand better, right? Because I've been doing it in a lot of different ways. So there you go. 3 different ways to make animated graphs. If you're not sure, if you're a student and it's okay with your instructor, do that first way. Print out 8 different graphs. That's fine. It's not about the graphs, it's about the physics, right? That's my feeling. It's about the physics. And this is just a tool to display that stuff. Okay. Hope that helps you, which is me in the future. And I'll talk to you later. Ending this.